In this image processing section, we will be using OpenCV a lot. Now, OpenCV is a Python library that is used for computer vision, which includes image processing, capturing video, detecting objects in images and in video as well. So in this section, we'll focus on image processing, and we can do image processing with OpenCV. Therefore, in this video, I will introduce you to OpenCV, and we will write a simple script which converts color JPEG images to grayscale JPEG images. So let's create a REPL for that. Convert image to grayscale. I'm going to use the shell now to explain you some things about OpenCV. So OpenCV can be imported as CV2, not as OpenCV, but you will get an error because we have to install it. So go to packages and search for OpenCV. So you install it as OpenCV, but you use it as CV2. So search for OpenCV Python, and that's it, OpenCV-Python. Press on the plus button and wait a bit. Now, OpenCV is based on NumPy. And NumPy is a library, a Python library used for numerical calculation. So you have these matrices, sort of 2D and 3D matrices, columns and rows with numbers. And when you think of an image is made of pixels. But each pixel is associated with a value, a number from 0 to 255. So basically, if an image looks like this, and it is made of pixels, let's say this is a small image made of 1, 2, 3, 4, 5 columns, and 4 rows. Now each of these will be a pixel with a particular color, right? They will have different colors. What that means is that each color is associated with a number actually. For example, let's say this would be 34, this would be 177. We would have a maximum of 255, not more than that. But actually, an image is not made of one matrix only, but it's made of 3 matrices. So that's times 3. And actually, each color is represented by a triple of numbers. Let's say this purple here would be represented by 65, I'm just guessing here, 127 and 254, right? This is purple. If we had another thing like yellow, it would be another triple of numbers, and so on. So every color is represented by these by different numbers. But what does each number mean? Well, the first one is usually the amount of red. So 67 means 67 units of red. And then we would have green, so let's say 127 units of green and 254 units of blue, so RGB. Although different systems could also change the order, so BGR or RGB. And so the combination of different amounts of red, green and blue would make a particular color. So to follow this example, we would have like 3 images stacked together, 3 matrices stacked together, and so each first pixel, so this first pixel of the second image here and that first pixel of that second image would represent, let's say, purple. So purple would be represented by the first number here, 34 or 75, and the second number in this matrix here and the third number in that matrix. So stacking those 3 matrices together makes up an image. Right, back to our code now. So installation of OpenCV was completed, so let me reload this page because it's frozen apparently, and let me Control L to clear the terminal, the shell, and then do import cv2, and this time it worked. So if you do dir cv2, you're going to see a range of methods that you can apply. For example, with cv2.rectangle, you can draw a rectangle on an image, JPG image or PNG image, etc. In this video, we're going to use this method, imRead, which means image read. So we're going to read an image. Now, to move forward with this video, you need to have a JPEG image here, or PNG or JPG. So for convenience, you can download the galaxy.jpg image from these lecture resources and then drag and drop it in here. So I just did that, and this image looks like this, so it's a color image. And now if you go to main.py and you import cv2, and then if you create a variable such as color and say cv2.imRead for image read, and provide the path to the image, which is galaxy.jpg in this case, and set 1 as a flag, which means load the image in colors. So if you wanted to get a grayscale, you'd say 0. 1 means get the color version. If I print color, this is what we're going to get. So it starts from here, and you see these 3, 1, 2, 3 square brackets. That means we're looking at 3 matrices. So basically, it's a complex structure because you have nested lists, and it's actually a NumPy array. That's how it's called. But basically what we have here is those 3 layers of matrices that I explained to you earlier. And these 3 matrices have the same dimension because it's one image but with 3 matrices representing each pixel. So if you want to see the number of dimensions, actually you could do print color.ndim. So 3. And lastly, let me print out the type of this object, just to convince you that this is actually a NumPy array. So NumPy ND array, which means ND n-dimensional array. It could have 1 dimension, it could have 2. In this case, it has 3 dimensions. Right, so our purpose was to convert this into grayscale. To do that, we need to load this as a grayscale image, and you would have to do cv2.imWrite. So another method of cv2 to write an image, and you should provide a path to the new image, galaxy.gray.jpg. And also, what do you want to write in that path? What NumPy array? Well, this one, color. So run that, and you see that a new image is generated. You open that and you'll see that it's in grayscale. And that's our script. This was just a small program just to introduce you to NumPy and OpenCV. Next, we're going to dive deeper and do some more complex image processing. Let's get started.